Okay, so this question asks us to consider the function f of x is equal to negative 8x cubed plus 12x squared minus 3x plus 1. And we have to find the equation of the tangent to the curve at the point 1, 2. So what we're going to first do is differentiate. So we get the derivative is equal to negative 24x squared plus 24x minus 3. And all we have to do to find the gradient is substitute our x value into the derivative function. So we get negative 24 plus 24 minus 3, which is obviously equal to negative 3 as these cancel out. So given that the gradient is negative 3, so we know that y minus 2 over x minus 1 is equal to negative 3 because we're using the gradient function here. So we get y minus 2 is equal to negative 3x plus 3. So therefore, y is equal to negative 3x plus 5. That's part A. Part B, we have to find the x-coordinate of the point of tangency. So this is because there's a second tangent to the curve y equals fx, which is parallel to the tangent found above. So what we're going to have to do is basically find this x-coordinate. So this is parallel to the tangent and it has the same gradient, which means that negative 24x squared plus 24x minus 3, which is the derivative of this function, has to be equal to negative 3, because obviously when you substitute the x value in, it should yield the same gradient. So if we rearrange, we get negative 24x squared plus 24x is equal to 0. If we factor out negative 24, we get negative 24 times x squared minus x is equal to 0. Factor out x, we get negative 24 times x minus 1 is equal to 0. So we have two solutions, x is equal to 0 and 1. We already found the one with x is equal to 1. So our solution is x is equal to 0. This is the x-coordinate over here. Now let's go into part C. So hence find the equation of the tangent line to f of x, y equals f of x, as parallel to the line found in part A. So we're given, well, we know the second x-coordinate is x is equal to 0. So we're going to use that as our coordinate. We just have to find the y-coordinate. So when x is equal to 0, well, that just means that with f of x, the parts containing x will become 0 since anything times 0 is 0. And we're left with 1. So our coordinate is 0, 1. Y is equal to 1. Coordinates 0, 1. So now what we're going to do is we're going to do the same thing. We're going to write our function as y is equal to negative 3x. We're using negative 3 because the gradient has to be the same for it to be parallel. Y equals negative 3x plus c. Substitute our coordinates in. We get 1 is equal to negative 3 times 0 plus c. As we know, anything times 0 makes it 0. So c has to equal y, our y-coordinate in this case, which is 1. So therefore, y is equal to negative 3x plus 1 is our answer for part C.